Today I'm going to talk about statistical computing. Now, most students think of statistical computing and with, oh, no, I wouldn't want to do that. That's too complicated. As it turns out, it's complicated to learn to use a computer. But to do statistical computing, you really don't have to have any more than the minimum knowledge of computing. You turn it on, and you type the word that starts your program, and then you have to learn a few keys that you press, or mouse, how to use a mouse. There's not really very much to learning how to use the computer when it comes to using these packages, these statistical packages. And once you get by those few minutes of learning how to do that, what you can do with the computer is save so much time. You've spent a lot of time this semester calculating things for homework. If you had a computer, you would not have to do the calculations by hand. Statisticians don't do these things by hand anymore. They press a button on a calculator and out pops the results. And so today I'm going to just show you what a statistician would really do, and non-statisticians, people, anyone who's using statistics, would do instead of actually doing things by hand. We mentioned Minitab many times. In fact, I showed you Minitab on several occasions. And we're going to use a little bit. Minitab is a package. Let me say this about some of these packages, Minitab. Minitab, for example, if you were to go out to industry, you're in industry, and the boss said, go buy Minitab, and you bought Minitab for your computer, it would cost $700. That's not a lot of money for an industry. However, that same package is available to students here on campus for $70, 10 cents on the dollar. There's also a student version of it, smaller, watered-down version, for $35. 70 and 35 are certainly within the range of students, and you can take it home with you, you can take it to work with you when you go, and you've always got it. And that's why I use Minitab here, because there are many students that I teach in other classes that actually have Minitab and use it and do all their homework and every assignment on a computer package. And Minitab is one that they can easily get and purchase. It's not the only one. We're going to talk about several. The business school uses Minitab. That's required of their students, how to use Minitab. So Minitab is the one we've been working with here. It's probably the easiest for us to talk about. I'm going to give, I don't know how well you can see some of these things. You can see the important one, the big equation here. This says regress C2 on variable in C3, put residuals in C4 and fit it in. You have to know what you're doing. You have to understand the commands in order to run Minitab. But they're not hard to learn when you're doing something, what the commands are. And the output is what's really interesting. You put some data in two columns, C2 and C3. And what comes out of this is this equation here, which is A plus BX. Y equals A plus BX. And A is 5.24 and B is 0.239. X happens to be time and Y happens to be words in this equation. And that comes right out. You don't do any calculation of A and B. There's no calculations that we saw many times, those sum of X minus X bar times Y minus Y, but we don't do any of that, really. That's before the age of computing. Now computers do it all. And it gives you other information. Here's the coefficient again. You might be able to read it. And this line gives you the coefficient and makes a test of it, of whether that coefficient is 0. The p-value for that test is 0.29, which says fail to reject at any reasonable level that the hypothesis that this number is 0. This could be 0. 5.29 is not significantly different from 0. You look at 5.24, and you say, gee, that number's not 0. There's no way it could be 0. But this says there's no evidence to reject the hypothesis that it is 0. On the other hand, this is 0.239. If someone were to say, that's 0, I'd look on this line, and it says 0.23897, which is what this is. And over here, it gives me a p-value of 0, which says I can reject at any level, because 0.01 is bigger than this, 0.05 is bigger than this, 0.1 is bigger than this. I can reject at any level that this number is 0. If you say this number is 0, I will call you just a liar to your face. Statistics says there's no way this number can be 0. It's too far from 0 to be 0. This number Well, that one could be 0, but this one can't be 0. That's what statistics can do. It can tell you definitely this one is not 0. And it spits it out on a line. That information is available. If I were to plot, well, I don't know how many of you plotted things by hand, but we talked about plotting things. If we say plot C5, C3, it will take data, pairs of data, and put them on graph paper. And where there's 2 asterisks in the same place, so it's hard to mark them, it will put the number 2 instead of an asterisk. So looking at this, we can clearly see where the data is on the graph. And we didn't have to draw any pictures at all. Once the data was in, the same data we were analyzing some other way, it draws a picture for us. And it can draw a really fine picture if we like. Here's the picture of new test versus IQ. And this is a graphics plot, a high-resolution graphics plot. Not asterisks, but a line. And here's the IQ down here. Here's the new test. And we can use this. We can use this directly. Just take our ruler, say, here's your grade on the new test. That's what it means in terms of IQ. So the output from the computer is this nice curve, which we can use directly. We do not have to draw pictures. Remember the sign test? We had to find the CDF, or the probability that x was less than or equal to some number. Well, this is how we do it. We don't actually find probabilities. We just say CDF of 5 binomial n20 p.5. And it will give us the probability that x is less than or equal to k, where k is 5, for the binomial with an n of 20 and a p of 0.5. And it says that probability that x is less than or equal to 5 is 0.0207. And I can use that in my t-test to decide whether I should reject or not at any given level. On the other hand, if I said, give me a CDF of 6 binomial 20 p point, it would say the probability that x is less than or equal to k, k being 6, is 0.0577. And I would know what to do then. And I didn't do any arithmetic. All I did was enter some numbers onto the screen and press the button. Let's say I put some numbers in C3, and I say, describe C3. Put my data in C3. Describe C3. What Minitab would do is describe it. It would say, oh, there's 22 observations, the mean. By the way, it means the average. Even Minitab says mean, when it really is the average of the data, of these 22 data points, 83.09. Here's the median. Here's the standard deviation. Here's the standard error of the mean. What they mean here is the standard deviation of the mean. That is this number divided by the square root of 22, which is n. Okay? If you take 44.34 divided by the square root of 22, you'll get 9.45. And it gives it to you. It tells you the smallest, the largest. It gives you the quartiles, that is, 25 percentile of the range of the data and the 75 percentile of the data. So there's information that comes out with just pressing a button. Remember the t-intervals, intervals that we made, confidence intervals? Well, we can get intervals of any kind. We could say, give me a t-interval with confidence 0.95 for the data in C3. So I put some data in C3 and I want a 95% confidence interval. And it spits out immediately. 22 observations, mean is 83.09, standard deviation, and here's your 95% confidence interval. Lower bound is 63.43, upper bound is 102.76. This is a 95% two-sided interval. I could have given one side, asked for one-sided intervals if I wanted. I just would put in a subcommand. But I asked for a two-sided interval, and that's what it gave me. Very easy, very quick, no hassle. Remember the t-testing, the chart we used? Well, we don't need a chart, really. We say t-test, that the mean equals 100 for the data in C3. So it says, I'm testing that mu, mean, equals 100 versus the mean not equal 100. It's a two-sided test I'm making here. And it says, okay, 22 observations, here's the mean, standard, and here's the p-value for that test, 0.088. Well, now, if I want to make an alpha equal to 0.1, 10% test, I look at it and I say, hey, this is bigger than that, therefore I can reject. I reject at the 10% level that mu is equal to 100. Someone said, make a 5% level test. I would look at 5%, oh, it's not bigger than the p-value, therefore I must fail to reject. Okay? I have to fail to reject. And if someone said make a .01 test, of course I would fail to reject, because 01 is not smaller than 0.88. Okay, so it really is easy to do these things. The hard work is taken up by the computer. Here's another one. Remember the two-way analysis of variance? Schools and sex, and we measured IQ. Well, this says factors are school and sex. The levels are, there are 7 levels of school, 2 levels of sex. And here's some numbers, the sources. Here's the degrees of freedom associated with schools and sex and interaction. Here's the schools by sex. Error. Error is what we call the within. Right? It's what we call the within. And here's the mean square, the variation. It says the variation within is 48. The variation in schools is 56. That's 1.17 times as big. Well, is 1.17 times as big significant? Is there a significant school effect? And the answer is no, because nothing's... 0.1 and 0.05 and 0.01, none of them are bigger than the p-value, and therefore I must fail to reject the hypothesis that there is no school effect. All schools are the same. No means are different. How about sexes? Are the sexes different? The variability is 223, which is 4.6 times as much variability there as the within. That gives me a p-value of 0.03. I can reject at the 10% level. I can reject at the 5% level. It means at 10% level and 5% level, I do not believe that the sexes are the same. However, if someone made a 1% level test, I must fail to reject and say, well, there's not enough evidence to say that the sexes are different. They may indeed be the same. How about the interaction? There is 9.6 times as much variability here than the within, and of course we can reject at any level that there's no interaction, meaning we really believe there's an interaction. Okay, that's just a review. Here's a one-way analysis of variance, this whole page. One-way analysis of variance, there's a factor, there's an error, which is the within. Here's the mean squares. The F ratio is very, very small. There's the rate. This is not smaller. The between is much smaller than the within. There's no error, no reason to doubt, no reason to expect that there's a significant group effect, because the group variation is so small compared to the within variation. And this is illustrated by the p-value of 0.9. There's no way you can reject a hypothesis with a p-value that is that much above 0.1. In fact, if it's above 0.1, we're not going to reject it all. And this shows you a picture. The output gives a picture which tells us exactly what's going on. Here are the means. Notice that the means don't differ from each other by very much. Here's a confidence interval for each mean. Look how big the confidence intervals are. That's the within. Within the group, the variability is very large within the groups. But between the groups, there's hardly any variability at all. So clearly, the picture shows us that there's no significant group effect. The groups are not different. We get this very quickly out of the computer. Now, Minitab, if you don't like to remember all the terms, you really don't have to. There are menus. You click on a menu and it pops down, and then you click on a piece of it and it pops across. And in this particular one, you can ask for a correlation or a one-sample t-test, and you tell it what you want. If you wanted ANOVA, you would pop on that. If you want regression, you'd pop on that. If you want time series, you would pop on that. Non-parametric, you'd pop on that. And it would give you a menu from which you can choose what you want to do instead of having to write out the commands. Okay? So most packages will give you menus to fill in. Minitab gives you this kind. All right, we said Minitab was used by the business school and lots of others. There's another one called Number Cruncher. Number Cruncher is the package of choice for education. If you're in education, you'll have to learn Number Cruncher, because they will have labs in it, and they will expect everybody know how to use Number Cruncher, how to do analysis with Number Cruncher. Now, you're not going to be able to see this. It's too small. Even if we zoom up on it, you won't see what's going on here. Too small to read. But what happens in Number Cruncher, the style is different than in Minitab. In fact, in all the procedures we're going to look at, the styles are different, but the content is really the same. What they do in this case, in Number Cruncher, is give you a full screen menu with lots of questions, and you fill them in. Do you want this? Do you want that? What's the alpha level? Do you want to do t-test? Do you want to do a confidence interval? Do you want to have a box plot, or do you want a histogram reported? Do you want to sort the data? What do you want to do? And it asks you, and you fill it in, and when you're all filled in, you press the button, and it gives you the answers. The answers will be exactly the same answers. The style of the output might be different. You might have to look around to find what you want, but you'll be able to find it. In fact, if you learn one package, you'll be able to go to another package and learn it very quickly, because everything's the same except the style. The statistics is the same. So Number Cruncher is a package used mostly by education and education-related fields. Another one, SAS, which stands for Statistical Analysis System. That's used by statisticians and by engineers. Engineers and statisticians will use this, and we have to be very, by the way, I should say this, Number Cruncher is also inexpensive. It comes in modules, little modules. Some modules do t-tests, and some modules do time series, and some modules do, and each module, the educational price is $5. You can actually get a module for $5. So you get the basic thing, which is maybe $30 or $40, and then you add $5 to it for each different kind of thing you want to do, and you've spent maybe $60, $70, $80, and you got the whole package of Number Cruncher. Because if you go on a street to buy it, it'll cost a lot more. SAS, on the other hand, Statistical Analysis System, I don't think you want to think about purchasing it for yourself. You have to sell your firstborn to pay for this. I shouldn't say that, because actually I have one of these systems on my PC. But the cost on the open market is so high that a company has to have it. One SAS program on its mainframe for all its employees to use. Tech has one system on its mainframe, and it has a site license for you to buy the use of this on your PC for a year. And you pay a price, a premium price, for 1 year's use of it, and then you got to give it back. It's an extremely expensive. It does a lot, but for what we do, it doesn't do any more than the others. It does the same thing. The style of the input is different. By the way, for SAS, you really got to know what you're doing. There's no menus. PC SAS has some menus, but generally speaking, SAS is very difficult to put in, and you should be either a statistician or engineer or have a good deal of education in SAS itself before you try using it. But once you do use it, it's the same as anything else. They all give you the same results. In this case, you might not be able to see it. What it is a test for independence, and it's giving the data here and the expected values here, and it gives on this line, it's giving the chi-square statistic. It's 2 degrees of freedom. Its value is 13.246, and the probability, the p-value, is 0.001. And that's the information you want, and it comes right out like it would come out from any other package. That's Statistical Analysis System. A great package, but extremely costly. Here's another one, SPSS. It's used, it says Statistical Package for the Social Sciences. It's used in all the social sciences, including psychology. And they swear by this one. And here's the same analysis we saw in SAS. It's a test for independence. It gives you the observed values. It gives you the expected values. And then on the bottom here, it gives you the chi-square value, 13.24, and the degrees of freedom, and the significance level, 0.0013. Same stuff you got before, a different number of digits perhaps, but the same output that you saw in the other one. So statistical analysis, Statistical Package for the Social Sciences, SPSS, is just another package. Many packages there be. You pick the one you like best and use it. I think what I try to point out is two things. One, it doesn't really matter what package you use, because they all give the same results. What does matter is that you know your statistics, because I've seen people use statistical packages who don't know statistics, and they put data in, and they get numbers out, and the numbers have labels on them, and they quote these numbers, and they don't mean anything. It's very easy to respond to questions and not know what you're really expecting the data to do. The only thing you need to know when you use a statistical package is statistics. You don't need computing. You don't really, in most cases, have to know how to use it. Even if you've never seen it before, you can follow the menus probably intuitively without reading up on them. But what you do have to know is the statistics. Don't ask it to do things which you know can't be done, because it will do it. That is, it will give you an answer. But the answer won't have any meaning at all. And unfortunately, this happens. Many times people will use these packages in lieu of knowing any statistics and say, well, I don't need statistics, I have a package. I want to do analysis of variance. I press the button that says analysis of variance, and I get some numbers out, and it says reject, so I reject. What am I rejecting? I don't know. It says reject, so I'm rejecting. You see, you have to know what questions to ask it. You have to know what it's answering when it answers. That's what's necessary. The other thing that I want you to realize is that, I forgot, they're all the same. They give you the same output. There's really no difference between them. You don't have to know anything to use them. You use them. The output looks different, but they're really all the same. Okay? If you do need a package, get any one of them that you can get your hands on and learn to use it, and it will save you some time later on. Okay? Good luck.